Alright guys, let's look at this problem dealing with the average value of a function on an interval. So I've got the same function written over here. I'm just going to show you the work. So the formula for the average value of a function on some interval from a to b is the definite integral of that function from a to b divided by the width of that interval. So here a is 0, b is 3. So for this function, this is going to be 1 over 3 minus 0, the definite integral from 0 to 3. And our function is negative 2x squared minus 1 dx. Alright, this is a polynomial, so how do I take the find the definite integral? I just find the antiderivative with the power rule. So I'm going to say this is, oops, I don't need that anymore because I'm taking the definite integral. So remember, how do I take a definite integral? I add 1 to the old power, and then I divide by that new power, which is 2 plus 1. So I'm going to end up with negative, I'm going to write it this way, 2/3 x cubed, right? So 2 plus 1 is 3, 2 plus 1 is 3. All right, and then minus 1, the antiderivative of negative 1 with respect to x is negative x. All right, and then I'm plugging in 3 into this, I'm plugging in 0 into this. And when I say I'm plugging these numbers in, I mean I'm literally replacing this x and this x with 3, and then replacing them with 0, although that's just going to make it go away because in both terms I have an x, so I'll have a 0 minus a 0, which is going to be 0, but that's what you do with a definite integral. Alright, 1/3, if I plug in 3, I'll have negative 2/3 times 3 cubed. Alright, minus x, again I'm plugging in 3 for x. Again, technically I would subtract negative 2/3. Subtracting a negative would be a positive 2/3. 0 cubed. And again, subtracting negative x would be adding, plugging in 0 for x. So that's what I mean by I plug in the upper number, I plug in the lower number into the antiderivative. That's what the definite integral tells me to do. Alright, and then it's just arithmetic from here. So 1/3, negative 2/3 times 3 cubed is negative 2/3 times 27 minus 3. These pieces are both 0, so I just write goes to 0. And then you can see here that 3 is going to go into 27 9 times. That's going to give me a 1/3. Negative 2 times 9 is negative 18 minus 3. Negative 18 minus 3 is negative 21. Alright, divided by the 3 is negative 7. So the average value of this thing is equal to negative 7. Okay, so I can type that in there, and I see that that's correct. You can also grab a Desmos calculator, and I'm going to do this from 0 is less than or equal to x less than or equal to 3. That's the interval that we're defined on. Notice there's negative 1, negative 2, negative 3 is way off the screen. If you just plug in, this thing's always decreasing on this interval. So if you just plugged in f of 3, you could see how far down you need to go. So negative 19. So I'm going to bust this out. I don't need to go that far to the left, so I'll do 0 to 3. And then the y's can go from, the smallest y needs to be down around like negative 20. And the biggest y can be around 0. And there's our interval. I'm going to zoom out just a little bit just so you can see it. All right, and what we're saying here, I'm going to define some variable to go between our intervals. So from 0 to 3. And then I'm going to say x is equal to a, but I'm going to go just between the function and the x-axis. So f of a is less than or equal to y, and that's less than or equal to 0. So it's only showing me this tiny little slither of the graph until I move it left or right. I'm going to make it dashed just so you can see what I'm talking about here, and I'll plug in the point a, f of a onto this graph as well and label it. So the way this works, and let me again, I don't need that much negative space down there. Let's go like to negative 20. The way this works, as I move this thing, that line that we see is just an x coordinate along our axis being plugged into the function, and this is the output we get. So the average value of a function on an interval, if you could imagine all these y coordinates being summed up, so every y coordinate that you see as I move along is being summed up together. And so what we're saying basically is, if you see those little green lines, those vertical line segments, it's like we're asking what's the average distance, what's the average length of those vertical line segments from 0 to 3. The thing is, for every number, it grows. Notice this thing is skipping ahead. Every time I move ahead, it's skipping like a 100th or 200ths. It's like moving up just barely anything at all. But I could, there's an infinite number of numbers in here. I could plug in, it's going to go from 0.26 to like 0.27 or 0.28. Well, I could plug in 0.26437.859. That's a number in between whatever number it gives here and the next number. There's an infinite number of numbers in here. And I could just keep going with this. And there's the number of numbers between 0 and 3 is infinite. It's uncountably infinite. There's so many of them, we couldn't list them all. Right? So it's an infinite sum. If I was going to come up with the average length of all these green distances from the x-axis to the curve, there's too many to literally list out and add up and count. But that's the job of a definite integral. A definite integral is for infinite sums. That's what the idea is. So you can actually check this. Desmos understands all that notation. So 3 minus 0, that's the 1 over b minus a. int in Desmos is for definite integral. I'm going from 0, press up to 3. Alright, I've already named my function, so I can just write f of x. But then you always have to write the dx. It has to look exactly like the formula in the book. And there's our negative 7. So we can always check our work with Desmos. Alright, now geometrically speaking, if I made a horizontal line from y equals negative 7 over this exact same interval, so 0 is less than x is less than or equal to 3, alright, just like the red curves interval. Another way to think about what the average value is if I came up with the area of this rectangle right here, alright, ignore the red part in there. Well, the area of a rectangle is length times width. So this length is from 0, that's a 0, to 3, so this length is 3, and we just said the height is the negative 7. So area equals length times width. That's 3 times negative 7, it's negative 21. So the area of that rectangle right there is negative 21 units. Well, if I just find the definite integral from 0 to 3 of that red curve right there, that's also negative 21 units. And what that means is, if I did f of x is less than or equal to y is less than or equal to 0, that green area, that has an area of negative 21. That also has an area of negative 21. So what we're saying is, if I, let me turn off the red graph. If I go from 0 to 3, the average value of a function is the idea of this is the area between the x-axis and the curve on an interval. The average value is a rectangle that could be made that would have the exact same area over that same interval. So the green and the rectangle have the same area. And what that means is this arced looking triangle has the same area as this arced looking triangle. You know, they both have the exact same area. They're not the exact same shape, but they do have the same area because this other part in both shapes completes the area being negative 21. So anyway, that's the visual interpretation of what we mean by the average value of a function. So y equals 7 is negative 7 in this case, is the average value of this thing. And so that means I could make a rectangle at negative 7 over the exact same interval, and it would give me the same exact area.